Hey, my name is Tom Brummett, and we're going to be doing our teaching project about creating structures in Smalla. We've looked a lot about evaluating structures, but we thought that learning how to create them would really help to further our understanding.
Okay, so I'm Ivan, and the structure that we decided to create within our Smalla language is a kind of a basic while loop. When you look at a basic while loop in C++ syntax, um, basically contains two parts. The first part is this loop condition, which is basically a Boolean expression that continues as the expression still evaluates to true. It'll evaluate the body of the expression, which is the second part of this while loop. Um, for our smallest syntax, we decided to use while E1 do E2, where E1 corresponds to that conditional statement within the while loop, and E2 is the body of the while loop that basically just continues to run and does the actual body or the meat of the while loop. We decided to use this syntax because it's very intuitive for both the programmer and the user. It just basically conveys what each expression is doing, and um, it allows for easy understanding. Okay, so for our implementation of this while loop structure, we have this constructor within our Scala language. Um, so basically, the first thing we want to talk about is this extends expression piece of this constructor. Basically, we want um, this constructor to show that this while loop becomes a subtype of expert, and basically acts as a part of expert, kind of like any other expression would. The second part is this case class. We decided to make this constructor a case class because it helps with pattern matching, kind of like what we would do with any other expression type within this class. By making a case class, it makes pattern matching easy. And then finally, we have these two internal expressions, E1 and E2, which, like said before, correspond to both that conditional part, the conditional part in the while loop, and the body.
So now we're going to talk about creating inference rules for structures we've created, because to ensure that we've created a good structure, we need to make sure that we can interpret it properly. So when we're creating this inference rule, there's a couple things we have to keep in mind. The first, of course, is checking the condition of the loop. If the condition is true, we're going to want to execute the body. And otherwise, of course, we'll want to simply exit the loop. In the case where the loop condition is true, we will then repeat the loop. Otherwise, of course, we've simply exited. So our first guesstimate of the inference rule looks like this, by which the first thing we do is attempt to evaluate E1. Of course, this is not the correct inference rule, and this is simply because if we just evaluate E1 first, then we'll just end up with a Boolean, which will cause our loop to either iterate forever if the condition is true, or never do anything if the condition is false. So when we're creating this inference rule, we need to have some way of keeping our original structure intact so that we can reference the original loop that caused this iteration. So our actual inference rule is going to look like this. And so there's a couple things to notice here. The first, of course, is the fact that when we start each iteration, E1 is evaluated in this if statement. And then based on that, it will either basically or essentially recursively call this while loop statement, or it will simply exit with this unit. And the reason we return a unit value or have that else u in there is simply because in the case where we don't, where the condition is false, we want to do nothing, and a unit value is equivalent to doing nothing. So we can see here that how this differs from the other one simply because in that if statement, we execute the body and then return to the original loop.
Now we need to talk about the type rule for this while loop. So the first thing that we need to make sure of is that E1 is of type T Boolean. We don't want to be able to be put integers or functions inside there. We get to put T Booleans, any expression that evaluates to a Boolean inside there. And the second thing is that the return type of the while loop is going to be a T unit. This is because you don't expect a while loop to return any specific value. You don't expect it to return an integer or something. So we want it to be as general as possible, and so it should return a T unit. So here's our initial guess at the type rule. The first one is that E1 evaluates to a type T Boolean in the type environment, and then you say that while E1 do E2, and the whole expression returns of type T unit. Turns out this is not correct because it does not evaluate the body of the while loop. So here we have an example statement that would be correct with this rule, but incorrect typematically. You can assign x equal to true inside the while loop as you see there, which would cause problems in the evaluation steps. So the correct type rule for this would be that we check E1 is of type T Boolean and that E2 is of any type tau. We don't really care what type E2 is as long as it evaluates to a type. Then we say while E1 do E2, that whole expression evaluates to type T unit.
All right, now I'm Tom. I'm going to talk about why we designed the language in the way that we did. So there's many different ways to define a language. We could have used a different structure. For example, we could have done while E1, do E2, and increment by E3. We chose not to do this because we thought it would just make it more complicated. We wanted our structure to be easy to interpret, and we want it to be intuitive to the user. We want it to be easy to interpret for programming and intuitive for the user because we want them to be able to look at our program and know what it does within a couple of seconds. We also could have used a different interpretation. We could have done a recursive function versus an if statement. It would just be a different way of going through the loop. Whatever, as long as it does the same thing, that doesn't matter to the user. That's based on what the programmer wants. We want to use the most efficient method, but if getting the most efficient method leads to a dramatic drop in or makes it much harder to interpret, then you might not want to do that. It's all based on all of these factors, and it's a combination of them that makes it the easiest to use, quickest to run, and easiest to figure out how it's running and what it's doing.
At this point, we ask our students to further their knowledge by completing the following two tasks. The first task is to attempt to implement the new while loop structure into the substitute, step, and infer type functions in Scala. The second part is to think about your own structure to implement in Scala. Maybe you might want to attempt a for loop or perhaps a switch statement. Regardless of your choice, it will help you understand more about these structures if you attempt these tasks. Thank you.